Alright, it looks like there's a problem with this picture. This pretty fly house does not have a hot tub. I think we're going to have to put one right about here. Up close, that area looks like this, and my friend and client who has this house was having a bunch of problems trying to find someone to build one, so I said, I can build your hot tub, man, no problem. And so began the design process. The location for this hot tub is behind their house on a deck area that would have to be partially demolished because it's going to be a hexagonal shape, and he wanted it half embedded in the hill and half embedded in the deck. And you can see in this picture that there's good power proximity to this, and eventually we decided to build the utility shed kind of behind the house on a little causeway up the hill, so that the utilities were all separate from the hot tub. The first thing I did was do a mock-up concept in SketchUp to get the proportions and the general layout. So we have a little deck that wraps around the back and a retaining wall that holds back the hill. And the hot tub itself is about half above the ground, half above the deck, and then half embedded into the earth. After a few iterations in SketchUp, we moved on to more advanced CAD modeling. For most any project I take on, I try to build a completely dimensionally accurate, comprehensive CAD model before I get started, although this model was developed in tandem with things we were discovering as we were excavating. The model is really helpful because we can try different things in CAD without, costing any money in the real world. Also, it's good for figuring out weights, volumes, material lists, things like that. I was able to use the CAD model to figure out how much tile we needed to order, how much insulation I needed to buy, approximately how much concrete we were going to need. Plus, with this model, I was able to generate several drawings that would help with the demolition and the layout and designing the concrete forms. Once the bulk of the design of the hot tub was completed in CAD, I actually moved on to pen and paper for the systems design. And it was a lot easier to quickly sketch and erase on paper than it would have been to do a full CAD model of all the plumbing. A little bit about the features of this hot tub. It's about 700 gallons, 650 gallons. It's going to have 12 massage jets. That's what you can see around the hexagonal shape. Those are going to hit your back from the seating position. In the footwell, there'll be 3 return jets, which is what's going to supply the heated water back from the heating system. And then there's separate intakes for the jet pump circuit and for the recirculation circuit. This is a 2-pump based hot tub system, so you have one pump that takes water from the skimmer and the drain in the bottom, passes it through a filter, the chlorinator, which is a salt generator system, and then through the heater. And I believe we have a couple other modules that we'll go through in more detail soon. But there's quite a bit of stuff that the hot water has to go through, and it's more efficient to offload the jet power to a separate pump. Now that pump just pretty much takes the water from the hot tub and sends it through the jets at high speed. So there's no restrictions in there with the heater or the filter. Another advantage of this is the hot tub is a little less likely to cool down when the jets are on, because if you have a single pump system, then the water speeds up through the heater and it doesn't take as much. One unique feature of this design is that we actually stick the jet plumbing tubes inside larger tubes. So you have a pipe within a pipe, and that allows us to pass the recirculation water around the outside of the jet pipe tubes. So when the jets aren't on and that water is just sitting there underground in possibly freezing temperatures, the recirculation pump is constantly running warm water around it. So there's a much lower chance that pipe will freeze. The whole system is electric, so we're not using a gas heater. We are using a 18 kilowatt electric EcoSmart pool heater, which is going to require 240 amp 240 circuits, so it's quite a bit of power draw. So we're going to have to add some electrical panels, disconnects, Here's a little more detail about the electrical system. We're adding a main disconnect for the heater and a secondary disconnect that actually pulls a circuit from the generator. This house has a generator on it. That way, in the event of a power outage, we won't be able to heat the hot tub anymore, but the latent heat in the hot tub will keep the water from freezing, and the generator has enough power to power the recirculation pump and drain the hot tub if need be. So if it's 0 degrees outside and the power goes out, there's still power at the house to drain the hot tub, preventing the pipes from freezing. We're really concerned because this house is in a cold climate that we have a lot of fail-safes to prevent any freezing from destroying the plumbing. As far as what's being powered in the pump house, obviously the pumps and the heater. We also have an Arduino-controlled relay system that will interface with the hot tub control panel that can turn on the lights and manage the jet pump, and will also monitor the temperature. And so there's a variety of extra control systems in the pump house. Again, here's more detail on the 2-pump circuit. You see under jet circuit, we basically have a check valve, the pump, and a regulation valve. And that's it. So there's very few obstructions for that 4 horsepower jet pump to blast water up these 12 jets. And then the heater circuit has a lot more of the maintenance stuff. So check valve, then the pump, then a drain valve so we can divert the water to a hose if we wanted to drain the hot tub. Then valves around the filter. We'll have the temperature being monitored. Then the heater with a bypass around the heater so that you can, so that maybe you don't have scalding water coming out of those 3 return jets. You could add in some of the unheated water back into that. We also have our salt generator, and what's not pictured here is a sacrificial anode, which we'll talk more about in the video about the pump house build out. That basically, any metal that's in your system, especially if you have salt and water in general, and this water is pretty hard, there will be corrosion, and the sacrificial anode is filled with zinc, and that will absorb some of the corrosion. Now that we had a plan together, it was time to start the build. The first thing I did was build this long materials ramp, because the hot tub site is located on a deck behind the house up a hill, and there's no way to get materials up there easily. And we're talking about gravel, stone, getting dirt down this ramp. So getting this set up was going to make my life a whole lot easier. When I first built this, I used a pulley system, and it took a couple seconds to pull the whole thing up, but it was a huge pain after a couple of loads. So I pulled the winch off my truck and connected it to a battery charger, which made an automated system. And with 9,000 pound capacity, this has not even shown any fatigue, and it's been really great for moving materials up to the site. Before I started actually demolishing the deck and digging, I built a couple workbenches and a whole tent structure to protect the site from the elements. It wasn't long before there was a 14-inch snow, and I was really glad that I prepared my work site. This is all about an ounce of prevention is worth a pound of cure, and anytime you're doing a project, I highly recommend taking the time to set it up so that you can work a lot more efficiently. Alright, that's it for this video. Next time we're going to start digging a massive hole in the ground, and this hot tub project will be well underway. Thanks for watching.